Now we can look at the circuit diagram of the gas detector. This has an Arduino UnO board, a buzzer, a gas sensor, and a 4-digit 7-segment display, all of them connected to their respective pins in the Arduino UnO board. So now let's have a brief look at the coding of the gas detector. The coding of Arduino is C++. Here initially we have assigned each LED A, B, C, D, E, F and G to each pin on the Arduino. Also, the digits D1, D2, D3 and D4 are also assigned to the respective pins on the Arduino UNO board. Now, to understand what these LEDs are, we can have a look at the figure. This is the 4-digit 7-segment display having the LEDs A, B, C, D, E, F and G and the digits D1, D2, D3 and D4. These D1, D2, D3 and D4 are common pins for each of these digits. So now we can come back to the code. Here the digits D1, D2, D3, D4 are initialized to 0. Then the sensor is assigned to A5. That is, the analog output of the sensor of the gas sensor is put to the pin A5. Then we have two variables I and j and num, where I is for loop and j and num are two variables which we will use in the program. Then we have this void setup. This void setup is a function we create at the top of every program in Arduino. Inside the curly brackets of this void setup is where we write the code we want to run as soon as the program starts. Then we have a pin mode where we can put a specific pin, that is 13 A, B, C or D, as to behave either as the input or as an output. Then there is this void loop where we execute the whole bulk of the Arduino sketch. This is where we write the main code. You can see an analog read function which we will discuss at the end what is that. Then the digits 1, 2, 3 and 4. What digit 1 is, like if we have a number 1003, then digit 1 will be 1 of the 1003. So these are just pure max. You can just understand that. Then we have put a for loop which runs from 1 to 50. Then this is what, like if the j value, that is j is analog read. Analog read is the sensor value we get. That is, analog read will give us a value between 0 and 1023 for a voltage of 0 to 5 we get from the gas sensor. So if j is greater than 350, we have kept it now 350, we can keep at any value such that it doesn't go above 1023 because that's the maximum voltage we'll get. That is, for 5 it will be 1023. For 0 volt of the sensor we will get 0, j is 0. So if j is greater than that value, then we will have like 13 is the buzzer. The buzzer will be high, so we will have a beep in the buzzer. So that's the code, and we will have each digit 4, digit 3, digit 2 and digit 1. Digit 1 is the first digit, like in the code what we have written. So this digital write is there, which is used to write as high or low value to a digital pin. The high is actually 5 volt and low is 0 volt. And then there is delay 4, Delay 4 means we are delaying the program by 4 milliseconds before executing the next line of the code. So now here what it's doing, like for each digit, first it will become low, that the digit won't light up. Then we will go to a function called display number. That function we have written down. See, we can see here. This is a void display index. The digit that comes inside that is the integer x. Now, then we have a switch case operating here. The switch case is like an if statement. The switch statement compares the value of a variable to the value specified in the case statement. When a match is found, the code is in case is run. That's what happened. Like when there is a match between this x and this case values, then a match is found and that is run. That is, for example, if it is 3, then this 3 is run, and we have put a break so that it ends there. Like the keyword break exits the switch statement. So that's what happens there. And once that function is run, then the digit is displayed, that display number. The digit is displayed on our LED 4-digit 7-segment display. That's what happens. Now here we have written here also we have made a function 0, 1, 2 and all, where we have used the same digital write function in Arduino, which is used to write as high or low. We have explained before also. So what is 0? We have seen the 4-digit 7-segment display. In that, if A, B, C, D, E and F is high, then it will be 0. That is G, the middle one. Middle LED won't glow. All the others will glow. Then we will have a 0. So this is how the program works. This is the unlock read function we just discussed before in the code. As each unlock pin is 10 bits, the number of values it can store is 2 raised to 10, that is 1024. So the output of unlock read will be a value between 0 and 1023. So when the gas detector works, we will be having a value between 0 and 1023. If the concentration of gas is high, we will be having a value nearing to 1023. If the concentration of gas is low, then it will be nearing to 0. This is the value that we will be seeing in the display.
So since we have got an idea about the project, we can see how it works. We have made the circuit over here. This is the Arduino UnO board, the sensor, the 4-digit 7-segment display, and the buzzer. This is the code in the Arduino software. I can verify it and I can upload it. So I have already done uploading it. So we can see how this works now. We are using a lighter here. The lighter has butane gas in it. You can see a number on the display. That is the output of the sensor. When I increase the gas concentration above 250, it will buzz. See, here I have set it to 250. So if the output of the sensor goes above 250, the buzzer will buzz. So we can see that. Now it's 119. So now I am going to increase the concentration of the gas. See, now it is 341 and it's buzzing. So that's all. This is how the gas detector works.
So finally, we can see how we can use this gas sensor to find the concentration of gas in ppm. We have seen before that the gas sensor has a variable resistor whose resistance changes based on the concentration of gas. So here we have R0, which is the value of resistance in fresh air, Rs, the value of resistance in the concentration of gas. So we know R0. We can find Rs from this formula, where Vin is the input voltage 5 volt, Vout is the output voltage of the sensor, RL is the load resistance. Here we can see. So this is R, the load resistance. These are all the different components of the gas sensor which we have seen before. So now we have Rs and R0. So from the ratio of Rs by R0, we can find the ppm value from this graph. So for all these gases, we can find their ppm from the Rs by R0 ratio. So this is the end of the gas detector project. Thank you.